Okay, Wildcats. Today we're looking at Thursday, September 13th, absolute value function or absolute value transformations, part 1. That's me on page 8. Now, I'm going to show you the absolute value transformation assignment for part 2, and that's going to needs to be completed before the class is over on Friday, September 14th. Okay, and then Monday, September 17th, test 1 corrections. Okay, so really, Thursday's video is going to be the only video all the way up until Tuesday. Tuesday, you'll probably have another video. Okay, so with that, update your table of contents. All right, now your table of contents are updated. Let's take a look at the notes. So at this point, you want to get some notebook paper. I suggest college rule, but notebook paper. Okay, absolute value transformations, part 1. That's going to be on page 8. So I'm going to pause for a minute so you can get some paper, and then we'll continue. All right. Absolute value information. It's the distance from 0, makes values positive. F of x equals the absolute value of x is the parent function. Domain of absolute value is negative infinity to positive infinity, and the range is bracket 0 to infinity. So if you would update that part of the notes. All right. Now let's look at the transformation portion. Get all in there. Yep, almost. All right. Absolute value transformations. So our parent function is f of x equals absolute value of x, which is a parent function. All right, now at this point, you're going to need some colors. I use blue, orange, green, purple, like a pink, and a red. Okay, so it'd be a good time to pause the video and get some colors so you can follow along with those colors. All right, so I've kind of updated, if you notice, the notes that we did with transformation before, because I think adding some color and doing it this way is kind of a little bit more efficient. Okay. So when the negative is in front of the a, it reflects over the x-axis. When a is greater than 1, it's a vertical stretch. When a is greater than 0 but less than 1, it's a vertical compression. When the negative inside of the absolute value in front of b, it reflects over the y-axis. Wow, that's a long bell. All right. When b inside the absolute value is greater than 0 but less than 1, it's a horizontal stretch. When b is greater than 1, it's a horizontal compression. When it's now, this is inside the absolute value. If it's plus h, it translates left. When it's minus h, it translates right. All right, and then the last part is if it's plus k outside of the absolute value, it's up. If it's minus k outside of the absolute value, it translates down. Okay, so if you would update your notes. Again, this page is going to go in your journal binder. Okay. All right. At this point, you probably want to take the staple out of the packet. Get that out there. That hurt. Long bell. Wow. All right. So, again, this page is going to be on page 8 in your journal binder. Absolute value means, for example, the absolute value of negative 5 is 5. That's because negative 5 is 5 units from 0, or away from 0. So really, absolute value means the distance from 0. Okay, it's the distance from 0. Okay. All right. Now I'm going to take a moment to add some lines in the table to try to help keep the work more organized. You might do the same. And actually, I should have, let me go back. You're probably going to need, it's probably going to go outside of the table. All right. So now we're going to complete the table and graph the parent function of absolute value, which is f of x equals absolute value of x. So f of negative 3, because x is negative 3, is the absolute value of negative 3. Well, the absolute value of negative 3 is a positive 3. So that point is negative 3, 3. Okay, so now f of negative 2 is the absolute value of negative 2, which the absolute value of negative 2 is 2. So that point is negative 2, 2. So then you have f of negative 1 is the absolute value of negative 1, which is 1. So that point is negative 1, 1. So then you have f of 0 equals the absolute value of 0, which is 0. So the point is 0, 0. So then you have f of 1 is the absolute value of 1, which is 1. So the point is 1, 1. So then you have f of 2 equals the absolute value of 2, which is 2. So the point is 2, 2. Then f of 3 is the absolute value of 3, which is 3. So 3, 3. All right. So there is the parent function of the absolute value. So let's look at the domain and range of the parent function. Domain left to right, okay? It's infinite in both directions. So the domain is negative infinity to positive infinity. All right, the range is from bottom to top. So the bottom is 0. So bracket, because it's included, 0 to infinity. All right, so we're not going to worry about this line. So I'm just going to mark a line through that. All right. Now let's look at some examples of evaluating. Okay. The absolute value of negative 3 is a positive 3. Example 2. Now, it says the absolute value of x minus y. Well, x is 3, y is 1.5. So it's the absolute value of 3 minus 1.5, which 3 minus 1.5 is 1.5. So the absolute value of 1.5 is 1.5. All right, the absolute value of 0 is 0. Now, example 4, the absolute value of 10 times 2 plus 3. Well, 10 times 2 is 20 plus 3. So the absolute value of 23 is 23. And the absolute value of negative 3/4 is 3/4. Notice all of the values of absolute value are positive because we're only talking about the distance from 0. That's why it's always positive, because you're talking about the distance from 0. All right, so remember, this page is going to go in your journal binder. And then this page as well is going to be on page 8 in your journal binder, okay? Now, if you notice, I took a moment to draw some tables for example 6, 7, 8, and 9. And I also drew some lines to separate transformations, domain, and range. So if you would, go ahead and take a few seconds to do that. All right, now that you have that, let's take a look, okay? So before we graph, I want to add this up here. F of x equals the absolute value of x. Now, we know from our previous problems, or a previous example, that we know that f of x equals x, our absolute value of x. We know it's negative 2, 2, negative 1, 1, 0, 0, 1, 1, 2, 2. Well, every absolute value function is going to have, well, that should be 0, is going to basically have these, okay? The only difference is we're going to move the vertex, the 0, 0, okay? So that's when we start graphing what we call by direction. We're going to use these as directions and not as points. So the first thing you want to do is you want to move the vertex. So this means the vertex goes right to up 1. So we were at 0, 0, but that tells us our transformation, we move right to up 1. So we go from here right to up 1. There's our new vertex, okay? So now we can use these as our directions. So -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. So these aren't points anymore. These are directions. So we know from this point, we go left 2, up 2. From this point, we go left 1, up 1. From here, we go right 1, up 1. And actually, the direction, it's not 0, 0 anymore. It's HK. This is our new vertex, HK. So from here to 2. And you could actually keep going 3, 3, 4, 4, 5, 5, and so on. Those directions are what give the absolute value its shape. So once you have that, connect the points. All right. So now, and actually, let me take a step before we do that. Now, that's one way to do it. Another way is you could go to your calculator, okay, and go to New Document, No, Add Graph, and then to get the absolute value symbol, you press this button right here, right next to the 9. When you do that, the absolute value symbol is right there. So you go down, and there's your absolute value symbol. So we press that, and we can type x minus 2 plus 1. If I press Control T, I now have the table. Now these are actual points, so I could graph these points. So I could go, like say, -2, 5. So I could go -2, 1, 2, 3, 4, 5. And then -1, 1, 2, 3, 4, 0, 3, 1, 2, 2, 1, 3, 2. So you can do it that way as well. Okay, so those are your two options when graphing. Okay. All right. So our transformations, we know we went right 2 units, and we went up 1 unit. Okay. So let's take a look at example 7. So again, we're going to graph by direction. Now, if graphing by direction doesn't work, I'm not going to do it in each example, but you could use your calculator to graph 7, 8, and 9, okay? All right, so first thing we move the vertex. So here, the +3 means we move left 3. So there's our new vertex. We're not going to do anything with the negative yet. We just know we move the vertex left 3. So we know our directions are -2, 2, -1, 1. Our new HK, which is there, 1, 1, 2, 2. But in this case, this is where the negative comes. We have to multiply the negative times the y direction. So we have to multiply all of the y directions by -1. So that's -2, -1, -1, -2. Remember, these aren't points, these are directions. So from here, we go left 2, 1, 2, down 2. We go left 1, down 1, right 1, down 1, 2, down 2. And again, you should see how the point should make that line. You can just keep going with the points and then draw your graph. All right, so transformations, we know we reflected the x-axis, and we went to the left 3 units. Now, almost forgot to do domain and range. Now I can do example 6 and 7 domain pretty much the same time. Domain of a quadratic is -infinity to +infinity. Okay, domain is always for absolute value, negative infinity, positive infinity. Now here, range, the bottommost number is 1, so bracket 1, and it's going to infinity. Now this is going up, so it's to positive infinity. Here, since it's reflected, we're actually coming from negative infinity to 0. All right, so if you would finish up example 6 and 7. All right, now let's look at example 8. All right, so again, we're going to graph by direction. Okay, so we know our vertex doesn't move anything, it's just at the origin. So we know our directions are -2, +2, -1, 1. In this case, our HK is 0, 0, 1, 1, 2, 2. But here, just like example 8, we have to, in example 8, we had to multiply negative. Here we have to multiply all the y's by 2. So that's 4, 2, 2, 4. So from here we go left 2 up 1, 2, 3, 4. Left 1 up 2. Again, these aren't points, these are directions. So right 1 up 2, right 2 up 4. And then connect the points. All right, and let me just show you the calculator one more time, because again, that's your other option. You could, to graph example 8, you go to new document, no, add graph, type 2. To get the absolute value symbol, you press the button next to 9, and it's already basically saved in that spot. So click there, press X, press Control T, and then you can, these are actual points. So like -2, 4. So -2 up 4, -1, 2, 0, 0, 1, 2, 2, 4. So you decide whether you're using a calculator or using graph by direction, okay? Either way is acceptable on the examples 6 through 9 and also in the assignment. All right, so a transformation, when a is greater than 1, it's a vertical stretch of 2 in this case. Domain, really simple. Again, it's negative infinity to positive infinity. Range starts at 0, so bracket 0 to infinity. All right, last example, example number 9. All right, so again, we're going to graph by direction. You can see that I've already knew that in my table I was going to multiply by numbers, so I made my y column much wider. Okay, so again, we graph by direction, so -2, 2, -1, 1, HK, 1, 1, 2, 2. Now, let me take a step back. We got to move the vertex. So the -1s, we move right 1. So there's a new vertex. And in here, it looks like we're going to multiply the y direction by 0.5. All right. So 2 times 0.5 is 1. 1 times 0.5 is 0.5. 1 times 0.5 is 0.5. And 2 times 0.5 is 1. So from here, we go left 1, 2, up 1. Here we go left 1, up a half. Here we go right 1, up a half. And then right 2, up 1. All right, so a transformation is now b is less than, or a is less than 1, so it's a vertical compression of 0.5, and it went right 1 unit. Domain, real simple, again, negative infinity to positive infinity, and then range starts at 0, goes up, so it's bracket 0 to infinity. All right, now at this point, you have two options. You could be working in teacher-led, and I'll go back over all the examples, or you could work in small group, okay? So at that point, you decide, and just, oh, almost forgot. So these are the 3 pages that should be in your journal binder. So this page, okay? This page, okay? And now here, I want you to make a little change. This is going to be the transformations part 2, and this is going to be due at the end of class on Friday, September 14th, 2018. So what I would suggest doing on Thursday is I would start this assignment and finish it on Friday because it's due before class is over on Friday. Okay. So with that, have a wonderful Wildcat day.